Moving on, this should be our last page. 16x squared equals 81. Need to solve this equation by factoring. In order to solve an equation by factoring, I have to get 0 on one side of the equation, everything else over on the other side. So if I subtract 81 on both sides, I'm going to be left with 16x squared minus 81 equals 0. Now 16x squared and 81 are both perfect squares, so I have a difference of squares now. And so this will leave me with 4x plus 9 times 4x minus 9 is equal to 0. And so now you should by now recognize how to do this how to solve this equation. And I'll have 4x plus 9 equals 0 or 4x minus 9 equals 0. And so here I'll get x is equal to negative 9/4, and here I'll get x is equal to a positive 9/4. So my answer on this problem then will be a negative 9/4 and a positive 9/4. On the next one, we can go about it a couple different ways. I'll show you both of them. First off, we're going to leave the fraction in there, and we're going to solve it by leaving the fraction in there first. 4/9 p squared and 25, those are both perfect squares. The square root of 4/9 is 2/3. So I'm going to have 2/3 p plus the square root of 25, which is 5. And then I'm going to have 2/3 p minus 5 equals 0. So I'll have the equation 2/3 p plus 5 equals 0, or 2/3 p minus 5 equals 0. And so if I subtract 5 on this one, I'll be left with 2/3 p equals negative 5. In order to get rid of a fraction in an equation, I have to take it times the reciprocal. So I take it times 3 over 2. If I take it times 3 over 2, I'm going to be left with p is equal to negative 15 halves. Over here, add 5 to both sides. Be left with 2/3 p is equal to 5, and then take it times the reciprocal. And again, p is going to be equal to a positive 15 halves. So my answer will be a negative 15 halves and a positive 15 halves. Now, the other way to do this equation is to get rid of your fraction first. And it actually works kind of nice because then you don't have to deal with fractions. In order to get rid of fractions, remember we've talked about this, it's been a while, but if you have a fraction in an equation and you want to get rid of that fraction, is you can take it times a denominator. So if I take both sides of this equation times 9, 9 times 9 times 4/9 is just going to be 4. So I'm going to have 4p squared minus 9 times 25 is going to be 225 equals 0, because 0 times 9 is 0. And so now I've got 4p squared, which is a perfect square, and I've got 225, which is also a perfect square. And so that's going to factor out to 2p plus 15, because the square root of 225 is 15, and 2p minus 15 equals 0. And so now I can say 2p plus 15 equals 0, or 2p minus 15 equals 0. And on the first equation, I'll get p is equal to negative 15 halves. And on the second equation, I'll get p is equal to a positive 15 halves, which is the exact same thing we got before using the fractions, but I think getting rid of the fractions is just a little bit easier. On the next one, got 18n to the third minus 50n equals 0. Remember, in factoring, we have to get a common factor out first if we have it. So if you should recognize here that the common factor is going to be a 2n. If I factor 2n, I'll be left with 9n squared minus 25 equals 0. Now 9n squared and 25 are both perfect squares. So I can apply my difference of squares law, which now I'll have 2n times 3n plus 5 times 3n minus 5 equals 0. Now I have three different terms here that I can set equal to 0. Either 2n equals 0, or 3n plus 5 equals 0, or 3n minus 5 equals 0. So I'll get three different answers for n. And that would be my answer. So three different terms can work for n in this case. On the last one, I've got a squared plus 14a plus 49. Now, remember in the last section I gave that little chart when we're factoring trinomials. The first thing you need to check for when you have a trinomial, when you have three of them, is for greatest common factor. If there's no greatest common factor, the next thing you need to check is see if is it a perfect square trinomial. Meaning, is that a perfect square? If so, is that a perfect square? If so, is 2 times the square roots of each equal to the middle term? So a squared is a perfect square. Square root of that is a. The square root of 49 is 7. And so now the question is 2 times a times 7 equal to this middle term? The answer is yes, it is. And so my answer then is going to be a plus 7. It's a plus because that's a plus right here. A plus 7 squared. It's a perfect square trinomial. On the next one, 9z squared is a perfect square, so it's going to, the square root of that is 3z. 1 is a perfect square, the square root of that is 1. So then the question is 2 times 3z times 1 equal to this? The answer is no, it is not. And so it is not a perfect square trinomial. And so then we'd have to go through our other factoring techniques to factor it. If you do go through other factoring techniques to factor this, you will eventually get to the point where you realize that this is a prime polynomial. And on the last one, again, we need to use our all of our factoring techniques to factor this. The first rule every time is factor out a greatest common factor. If I look at 8m to the third minus 24m squared plus 18m, 2m is what they all have in common. And so if I factor out a 2m, I'm going to be left with 4m squared minus 12m plus 9. And now inside of the parentheses I have a trinomial. I need to check and see if I can factor that. And again, if I have a trinomial, the first check is to see if it is a perfect square. 4m squared is a perfect square. The square root of that is 2m. 9 is a perfect square. The square root of that is 3. So then is 2 times 2m times 3 equal to this? Well, 2 times, equal to this, not this one, this one. 2 times 2 is 4, times 3 is 12m. So my answer is yes, it is. So this will factor then to 2m, and then since this right here is a minus 3 squared. Next one, solving the equations. I've got 18r squared minus 8r plus 1. Again, before my first step in factoring a trinomial is greatest common factor. There are no greatest common factors. My next step is it a perfect square? 16r squared is a perfect square. Square root of that is 4r. 1 is a perfect square. Square root is 1. So 4r 2 times 4r times 1 is equal to 8r, which is what I need it to be. So I'm going to have 4r minus 1 squared is equal to 0. And in this section, we learned that we can take the square root of a perfect square and be left with just 4r minus 1 is equal to the square root of 0, which is 0. And then I add 1 to both sides and divide by 4. I'll get r is equal to 1/4. On the next one, let's check and see if this is a perfect square. X squared is a perfect square. The square root is x. 9 is a perfect square. The square root of that is 3. So 2 times x times 3 is 6x, which is what I'm looking for. And so this is going to factor then to x plus 3 squared equals 49. And again, I can apply the square root to both of them. The square root of x plus 3 squared is just going to be x plus 3 is equal to the square root of 49 is 7. Now, the square root of 49 can also be negative 7. So I also need to say that the x plus 3 could equal negative 7, because a negative 7 times a negative 7 is a positive 49. So the square root of 49 can be positive or negative 7. Subtract 3 on both sides, I'll get x is equal to 4. Over here, subtract 3 on both sides, I'll get x is equal to a negative 10. And so for an answer, I'll have 4 and negative 10 as my answer. Okay. That should be the entire chapter review. I hope you were able to follow along. If you have any questions, I'll be back at school on Tuesday morning. Come see me during seminar, and I'll help you on any questions you have. Don't forget that next class we will have a test on this. So please be prepared and bring me any questions you have. Thanks.